Have you ever had your plans ruined by the weather? What if I told you I have an idea how to stop hurricanes from wrecking your day, and that it involves liquid nitrogen? How exactly would liquid nitrogen stop a hurricane? How much of this icy cold substance would we need? And how would we pull this off? This is What If, and here's what would happen if you could freeze a hurricane. Wait, why would we need liquid nitrogen? Couldn't we just get by with a lot of ice?
I don't believe this.
Well, in 1947, Nobel Prize-winning chemist Irving Langmuir led a United States military experiment to pour ice into Hurricane King to make it lose its strength. It didn't quite go as planned.
Oops.
And that isn't even the craziest thing we humans have come up with. Some of us would be happy to blow up a hurricane with a nuke. Or push a swirling storm away by pointing a lot of fans at it. But that's a story for another time. For now, let's get back to liquid nitrogen. Nitrogen has a boiling point of minus 196 degrees Celsius, and it has the power to freeze things instantly. And if we poured some liquid nitrogen into a baking hurricane, it should make it go away. But how exactly would we do it? Why does cooling a hurricane sound like a great idea? Well, hurricanes happen when warm ocean water causes the rise of moist air from its surface. This creates a cycle of clouds that form and spin rapidly. As particles get heated, they move faster and spread out farther from each other. That makes the winds blow faster until they eventually grow into a violent storm. Warm water is what drives hurricanes. And the easiest way to stop this disastrous storm is to cool the ocean water. The idea is simple. If you released liquid nitrogen into the ocean, it would instantly evaporate. And warm water would act as a fuel for this evaporation. As the water particles were losing their energy to the nitrogen, water molecules would begin to slow down. They would come closer and closer together until they formed ice. The cooler temperature would then slow down the winds, and that would end the storm. Theoretically, if only it were that simple. We know that hurricanes thrive off warm water and warm, moist air. And we know that cooling down the water and air around the hurricane should stop this disaster. The problem is, hurricanes are large. The central part of a hurricane, called the eye, can be anywhere from 30 to 65 kilometers in diameter. Your best bet would be to freeze the hurricane all around, not just its eye. The hurricane is traveling at speeds of 120 kilometers per hour, and that makes its average diameter roughly 60 kilometers, and its circumference about 500 kilometers. So, by our calculations, to surround a hurricane and freeze it, you would need over 32,000 metric tons of liquid nitrogen. That would be like having 16 Olympic-sized swimming pools filled with the stuff. That's a lot of liquid nitrogen to transport. And how could we even deliver all this to the hurricane's location? Well, I'd say we would need a lot of helicopters. The biggest heavy lifter of the helicopter world can carry about 20,000 kilograms. So if you got your hands on this tech, you'd require over 1,600 of these copters to carry the load. That sounds like a pretty expensive endeavor. Now, imagine you had all the necessary resources and you were about to dump all that liquid nitrogen into the ocean. Now what? Well, if you were one of those brave volunteers transporting the liquid nitrogen, you should be ready for one thing.
I'm ready.
It would be painfully difficult to breathe. That's because once you released it into the water, the liquid nitrogen would evaporate. The air around you would have too much nitrogen and not enough oxygen, so better grab an oxygen tank. But that's just the beginning of the trouble. Freezing that much of the surface of the ocean could block sunlight from deeper waters. This would interfere with marine plant photosynthesis. Marine plants form the base of the food chain in the ocean. They provide nearly half of the oxygen that we breathe. And don't get me started on how unbearable life would be without oxygen. You'd probably have to carry tanks around and figure out a way to help the animals. Looks like you'd be better to wait for the hurricane to die off naturally. Usually, that takes about 12 to 24 hours. Freezing a hurricane with liquid nitrogen would be expensive, dangerous, and likely impossible. But if you like the idea of using liquid nitrogen to cool something down, maybe you could pour it into a volcano. Well, that's a story for another What If.